In this section, we're going to discuss how to solve system of linear equations in two variables. These are our objectives. So first of all, we'd like to verify either a given order pair is a solution of a system of a linear equation or not. We are going to discuss how to solve system of linear equation using two methods, substitution and elimination. And then finally, we're going to see, some application problem. So linear equation in n variable can be written as this way: a1 x1 plus a2 x2 plus dot dot dot. That means keep going like this uh, until you finish all the variables equal b. Here make sure that this a1 a2 an and b, they are some real numbers, whereas x1 x2 and up to xn, they are variables. I can give you examples. For example, let's say 2x plus 3y equals 6. This is um, this is an equation in two variables, x and y. Okay, so you might see equation like this: 3x equals 6. This is an equation in one variable. If you want to keep adding these variables, you can also write 5x y 3z equals 7. This is equation in three variables. So linear means, whenever you see variables, the power, the exponent on the variable, there is nothing. That means the power is 1. No matter how many variables you have, either it's a one variable or two variable or three variable, the power should be 1. That means linear. If we are talking about two variables or one variable, they give you a straight line. That's the equation for the straight line. This equality sign means equation. So linear equation in n variables, n is just a general term. It might be one variable or two variable. In our case, in this section, it's a two variable. So as I mentioned, we're going to talk about a system of linear equations. So we're going to take two equations in two variables. That's called system of linear equation variable. For example, you might see 3x plus 5y equals 10. That's one equation. Because there are two variables, and if you would like to find out the solution means value of x and y, you need at least two equation in those two variables. 5x plus 3y equal maybe 15. So as you can see that these two equations combinedly, we can call them as a system of equation in two variable. Our goal is to find the x and y such that x and y should satisfy both of these equations. So in this example, we're going to check either -1 comma 3, which is a point, which is also called order pair, the solution to these two equation or this system. So for that, first of all, you need to put x equal to -1 and y equal to +3 in the first equation. And if you do that, this equation becomes, wherever you see x, just replace that by -1. Wherever you see y, just replace that y by +3. And then let's see what happens. 3 times -1 is -3. 2 times 3 is 6. And on the right side, there is a -9. On the left side, if you do simplification, you get -9 equal -9. That is a true statement. That means this order pair is a solution of this equation, equation 1. We're going to do the same thing for the equation 2. We're going to replace this x by -1, y by +3. Let's see what happens. It gives you 2 equal 2. That means that also gives you the true statement, meaning this order pair, this point, is a solution for both of them. That's why we can say that this order pair is the solution for this system. Okay, so verifying solution to a system of linear equation in two variable. So when we try to verify the solution, there are only three possibilities for the graph of a linear system of equation involving two variables. Let's assume that this is the system we have given, and if we try to plot the graph for the equation 1 and equation 2, the solution of this system gives you three output, gives you three different conclusions. The one is, if you plot the graph, the lines can have different slopes and thus intersect at a single point. Systems that have at least one solution are said to be consistent. This consistent system has exactly one solution, so it is said to be consistent and independent. So whenever we deal with a system like this, where we try to solve for this system, we might have three different solutions, and that we can see by using graphs. And from the graphs, we might have three different conclusions. The first one is, we might have one solution, and if that is the case, that's called consistent. Second one, the two equations can be different representation of the same line and have the same graph. In this case, there are infinitely many solutions. Because the system has at least one solution, it is said to be consistent. This consistent system has infinitely many solutions, so it is called consistent and dependent. In previous case, it was it we had just one solution, so that is called consistent and independent. Whereas for more than one solution, um, infinitely many solution, it's called consistent and dependent. I'm going to show you the graph for this one. Finally, no matter what, if you try to plot the graph for two different the lines here for the system, then if those lines are parallel, then they are not going to intersect with any point. That means this system is called inconsistent. Let's look at the graph here. As you can see that these lines, blue and red, they represent one equation, and you can see that they are intersecting at just one single point. This kind of system is called consistent and independent. Here, both of the line, they are overlap, so we see them as one line. So that's called consistent and dependent, because they are same line. Finally, you might have this situation where line never intersect and you don't get any solution. That's called no solution. So the main goal when we uh, involve with the system of equation, when we try to solve system of equation, uh, you know uh, our goal is to find the value of action y. Graphing is one way for finding the value, but graphing is might not be always practical. So that's why we have to learn different ways to solve system of equation. And the first way we're going to talk about is substitution method. This method, first of all, we need to choose an equation from two equations. We need to choose one of them and solve for one variable in terms of the other variable. So there are two equations, and choose one of them, and then from that one solve one variable. So while choosing, it might be a little bit tricky, but choose that one which gives you easily one variable. The second one, substitute that expression from step 1 into the other equation, and step 3, solve the equation in one variable, and finally substitute the value found in step 3 into the one of the original equation to find the other value of the other variable. So these are the steps when we use the substitution method. I'm going to show you one example. So solve the system of equation by using the substitution method. So first of all, look at here, there are two equations. That's why it's called system of equation. And out of these two equations, we need to choose one equation such that it would be easier for us to solve for at least one variable. By looking these two equations, if I choose second equation, then for me it would be easier to solve for one of the variable. I can solve for x or I can solve for y, because it doesn't have any coefficient in front of x and y. So if I choose the first one, then I have to bring let's say if I choose the first one and I want to solve for x, then first of all I have to bring this 3y to the right side, and then after that I also have to take care of this 2. But here for the second one, I don't have to worry about the coefficient in front of the variable. So what I'm going to do is I'm going to choose equation 2, and solve for x. Take equation 2 and solve for x. So I'm going to take equation 2 and solve for x. Solve for x means I'm going to subtract y from both sides. By doing that, x would be negative y plus 5. So now I do have the value of x in terms of y. I'm going to substitute this value of x in another equation, which is equation 1. That's why it's called substitution method. Substitute this value of x in 1. That's what we discuss here, choose an equation and solve for one variable. We did that. Substitute the expression from step 1 into the other equation. That's what we're doing here. Substitute this value of x in 1. So wherever we see x in equation 1, there is a 2 and there is a x. Instead of x, we're going to now use negative y plus 5. So negative 3y equal negative 5. By doing that, as you can see that this equation becomes equation of y. Now I'm going to use the distributive property of property here. So I'm going to write it down. Negative 2y, positive 2 times 5 is 10, negative 3y equal negative 5. So our goal is to solve for y here. So I'm going to use this space negative 2y and negative 3y. If I combine that, it gives me negative 5y. There is still 10, and on the right side there is a 5. Our goal is to solve for y, and for that we have to bring this 10 to the right side. So if I do that, this positive 10 and negative 10, it will be cancelled out. And on the right side, I'm going to get negative 15. So our goal is to solve for y. There is still negative 5 on the left side. So I need to get rid of this negative 5, and that's only possible if I divide both sides of negative 5. I did the division because opposite of the multiplication is division. So whenever I divide both sides by negative 5, I get isolated y, which is if you divide negative 15 by negative 5, it will give you 3. So that's the value of y. We're going to find the value of x, by using this value of y. And for that, we can use this equation. The equation we got, let's say this is the equation 3. We can use equation 3 and substitute the value of y, and it will help us to find the value of x. So using 3, if I try to find the x, my x would be negative y, which is negative 3 plus 5, which is positive 2. So the value of x is positive 2. So the solution for this system of equation is x equal 2 and y equal 3. Remember, after finding the solution, we always have to check, either our solution is right or wrong. So we have to, do the checking. So this is the system of equation. We are going to plug x equal to 2 and y equal to 3 in this system. Okay, so x equal 2 and y equal 3. This order pair, we are going to substitute this value back in equation 1 and 2, and both of them should give you the true statement. So that's the checking part. Check. So the system is, as you can see, that this is 2x minus 3y, 2x minus 3y equal negative 5. That's equation 1. And x plus y is positive 5. That's equation 2. Now to check it, I'm going to just plug x equal to 2 and y equal to 3 in both of these equations. Let me just use different color here. So x equal to 2, 2 times 2 minus 3 times 3 equal negative 5. 2 times 2 is 4 minus 9 equal negative 5. Negative 5 equal to negative 5. That's the true statement. So there is no problem with the first one. For the second one, 2 plus 3 equal 5. That is 5 equal 5. And that is also true statement. So that means this solution, x equal to 2 and y equal to 3, is the solution of this system. 2, 3. So we have one single solution. That means it's consistent and independent. So if we try to plot the graph of these two lines, we are going to see these two graph, and as you can see that they are intersecting at 2 and 3. Okay, So there is another way for solving the system of equation, and that's called method of elimination. In this method, first of all, we need to choose a variable to eliminate. So we have two different equations. From those two different equations, we want to eliminate one of the variable. Like for example, let's say you have the system of equation in x and y. You want to eliminate either x or y. For that, we need to multiply one or both equation by an appropriate non-zero constant so that the sum of the coefficient of one of the variable is zero. And after that, add the two equations together to obtain an equation in one variable, and finally solve for that variable. And after solving for one variable, plug the value of one variable to one of the original equation to find the another variable. So I'm going to show you one example here. There is a negative 2x positive 5y equal 29. That's the first equation. 3x plus 2y equal 4. That's the second equation. Method of elimination means, we need to multiply equation 1 or equation 2 in a way that we could, eliminate one of the variable. As you can see that there is a negative 2x and there is a positive 3x. If I want to, eliminate x, then I need to multiply the first equation by 3. That's why I will get negative 6 in front of x, and second equation by 2, and that's how I get the 6x for the second equation. So let's multiply the first one by 3 and second one by 2. When we multiply, we need to multiply every single terms of the first equation or second equation by these numbers. So if I multiply by 3 for the first equation, my first equation becomes negative 6x plus 3 times 5 is 15y, and then 3 times 29 is um, 87. Similarly, if I multiply the second equation by 2, it's going to give me 6x plus 8y. Look at here, I'm multiplying each of these number by 2, then 8. Finally, after multiplying this equation, our goal is to eliminate the one of the variable from these two equations. So we need to add such that we should be able to eliminate one of the variable. In our case, it's easy because you can see that there is a negative 6x and there is a positive 6x. If we add these two equations, this negative 6x and positive 6x, they will be cancelled out. For the y term, it will be 23. 15 plus 8 is 23 equal it's 95. So now if we try to find out the value of y, just divide both sides by 23, and that will be our the value of y. The value of y is 95 over 23. If you want to use the calculator, if it can be simplified further, then you can do that. Okay, 95 divide by 23. Can we the calculator to simplify it? Let me use my calculator here. I am dividing 95 by 23, which is not, it gives me some decimal number, so I'm just going to use the fraction here. So now, after finding y, let me check if I did something wrong. 29 times 3 is, okay, that's good. 3 times 5 is 15. Yes. 4 times 2 is 8. 3 times 2 is 6. 2 times 2 is 4. Yes, I did that mistake. Look at here. 2 times 2 should be 4. It's supposed to be 4. But I wrote 8 here. So 15 plus 4 is 19. So I have to divide both sides by 19. So 95 divided by 19 is, what is that? 5. That's 5. Yes, that's what I was doing wrong here. So it's 5 actually. So now after finding the value of one variable, I go back and pick one of these equations. So I'm going to pick the first one. I'm going to put y equal 5 in the first one to find out the value of y. Put y equal to 5 in 1 and find x. Okay, so negative 2x plus 5 times 5 equal 29, and that is negative 2x plus 25 equal 29. So I'm going to just subtract 25 to solve for x, and that gives me negative 2x equal 29 minus 25 is 4. So now we just have to divide both sides by -2. By doing that, x will be -2. So x equal -2 and then y equal to +5. This is the solution for this system of equation. Okay. Okay, so remember, after finding the solution, always check. I'm not going to check it here, but that's for you to do. Okay, just plug x equal -2 in first equation and y equal +5. That should give you the true statement. Similarly, put x equal to -2 in the second equation and y equal +5 in the second equation. That should give you the true statement. Okay, now 5 steps I'm going to talk while solving the uh, word problem using the system of equation. The first thing is read the problem several times until you understand what is being asked, because if you don't understand the question, the probability of finding the right answer is very low. So read the question a couple of times. If possible, try to draw diagram, charts, or anything, any table that might be helpful to understand the question. After that, always choose variables that describe each unknown quantity. Because we are planning to use system of equation, there should be some unknown, and we are trying to find out those unknown. So always introduce like x and y for those unknown and solve the system of equation for x and y. Step 3, write a system of equation using the given information and variable. After introducing unknown, you have to write down the system of equation. Finally, you have to solve that system of equation by using any method you have learned. You might use substitution method or elimination method for now. Then finally, after solving that system of equation, after finding those unknown, make sure that you have answered the question and check all the answer to ensure they make sense. So for example, let's say this is the word problem, a word problem, and we are trying to use the technique of solving system of equation to solve this word problem. Together, teammates Pedro and Ricky got 2,688 base hits last season. Pedro had 280 more hits than Ricky. How many hits did each player have? So we don't know how many hits they made. So there are two unknown. One is hits made by Pedro. Another one is hits made by Ricky. So let's say X is number of hits by Pedro and Y is number of hits by Ricky. Now, if we go back to this problem, it says that together as a teammate, they made 2,688. That means together. So that means if you add their hits, it would be 2,688. That's our first equation. The second equation is Pedro had 280 more hits than Ricky. So that means if you subtract the number of hits made by Ricky from the number of hits made by Pedro, it should be 280. So that's the system of equation, and we want to solve for x and y. Here I can just use the elimination method. I can just add 1 and 2 so that I can just eliminate y here. So I'm going to do that here. Uh, so we need to solve x plus y equal 2688, x minus y equal 280. So I'm just going to add this to equation. So if I add this, positive y and negative y will be cancelled out. On the left side I'm going to get 2x, and on the right side after adding this I'm going to get 8 2968. To solve for x, I just have to divide both sides by 2, and it gives me 1484. So the number of hits made by Pedro is 1484. 1484. And we know the difference between the the Pedro and Ricky is 280. So for the Ricky, it should be 280 less than Pedro. So I'm going to put x equal to, we can use any one of this equation. So let me just use equation 1. I'm going to use equation 1. Use equation 1 to find y. So we know x plus y equal 2688. I know x is 1484. So to find y, just subtract 1484 from both sides, 484, and that gives us y equal 4021, 1204. So that's the solution of this system of equation. So you can always check either that's the right or wrong by plugging x equal to 1484 and y equal 1204 here in this equation. The sum of those two numbers should be 2688. The first x value should be greater than y value by 280, and that's what we can see here. So now you can always go back and answer the question we have asked. Let's say the question is how many hits did each player have. So to answer that question, you always have to write down that in word. So the number of hits made by Pedro is 1484. Similarly, number of hits made by Ricky is 1204. Okay, the difference you can see that that's uh, 280. That's how we solve this word problem, and we use the system of equation solving technique to solve the word problem.